Welcome to Billionaire Investment. A massive $25 billion is being poured into a dry Texas plain to build a 1.4 gigawatt AI mega campus, power on the scale of an entire city. Who's bankrolling this steel giant? Which banks, funds, and GPU titans are quietly steering the game? And when servers drink power like a small state, can ERCOT, Texas's water resources, and the grid truly handle it? This isn't just infrastructure. It's a wager that could define the future of global AI. And today, we're going to strip down Frontier's money map. The new data center reality legacy data centers are already outdated in the AI wave. What we're seeing now is a city-scale supercomputer, individual racks drawing up to 250 kilowatts, industrial-grade liquid cooling, and near 24/7, approximately 100% load. Amid this hunger for compute, Frontier emerges as Vantage's colossal bet. 10 buildings across 3.7 million square feet, designed to host some of the densest GPU clusters on the planet. Peak capacity tops 1.4 gigawatts, roughly a mid-size US city's power demand. The first building is slated for delivery in late 2026, kicking off an infrastructure chain that could redraw the global tech map. If Frontier lands as planned, Texas won't just be the oil capital, it will become America's leading AI growth pole, influencing the pace of the entire AI economy. Where it sits and how big it gets set in Shackelford County, about 30 minutes from Abilene and just over 200 kilometers, approximately 125 miles, northwest of Dallas-Fort Worth, Frontier is laid out like a true AI headquarters. The site spans 1,200 acres, more than 900 football fields, and targets 1.4 gigawatts of critical IT load, the largest in Vantage's global portfolio. Design highlights 10 ultra-high density GPU halls fully liquid cooled for Blackwell/Hopper class racks, closed loop chiller systems that recirculate almost all water, saving billions of gallons annually while aligning with LEED sustainability target. At full stride, Frontier is expected to create 5,000 plus direct and indirect jobs, from electrical engineers and infrastructure techs to local materials, services, and logistics suppliers. Status: site and high voltage substation works are underway. Building 1 is targeted for late 2026. The 10-building campus will open in phases, paced by ERCOT interconnection milestones and AI cloud lease signing, with full build-out eyed for 2028 to 2029. Why Texas pulls this off? Texas has long been America's energy powerhouse, a natural magnet for mega-scale AI infrastructure, low-cost, abundant power. ERCOT's wholesale prices rank among the nation's lowest, thanks to large natural gas reserves and flexible load balancing. Renewables leader, number 1 in U.S. wind, 40 plus gigawatts installed, and rapidly scaling solar, approximately 6 gigawatts added in 2024, making it easier to lock in long-term clean energy PPAS/VPPAS. Pro-business policy, low taxes, fast permitting, and local incentives such as property tax abatements and infrastructure support for projects worth tens of billions. At the center is ERCOT, Texas's independent grid operator. It enables large investors like Vantage to negotiate flexible PPAs, from 20-year wind to shorter-term solar, to feed the 24/7 baseload that dense GPU clusters demand. The hard part: grid and supply chain. The biggest challenge is plugging in 1.4 gigawatts of capacity. Requires 345 kilovolt substations and dozens of new transmission lines. Transformers, switchgear, and extra high voltage gear face multi-year supply chain backlogs, forcing early orders and contracts to avoid delays. Site advantages. The Shackelford County tract checks the boxes. Flat, contiguous, 1,200 acres, room for 10 buildings and full liquid cooling infrastructure, close to high voltage corridors and national fiber backbones, compressing electrical and network lead times, away from dense residential zones, reducing land use conflicts and easing permits. Together, that creates a platform for a multi-phase mega campus, expandable without rip and replace, while maximizing Texas's cheap power plus renewables plus flexible policy. Water, the decisive variable. Texas endures frequent, prolonged droughts. Surface and groundwater are under pressure. To avoid the multi-billion-gallon draw of conventional designs, Frontier uses closed-loop chiller, pumping water through heat exchangers and back into the loop with minimal evaporation. The result, dramatically lower consumption and stable cooling for ultra-dense GPU. But at full 1.4 gigawatt load, big questions remain. What will WUE, water usage effectiveness, look like in real-world operation? Transparent reporting will matter to communities and investors. Can reclaimed water from local treatment plants cover the loop's minimal losses? How will Vantage coordinate with the Texas Water Development Board to ensure residential and agricultural water priorities remain protected? Clear, transparent answers on water use, WUE, and ESG aren't just about permits and sustainability scores. They are the key to Frontier's stable operations for decades. Frontier's total investment is estimated at $25+ billion. To raise capital at that scale, Vantage is using a multi-layered capital stack consistent with top-tier AI/data center infrastructure deals, large construction debt, a syndicated construction loan led by global banks drawn by milestones. Tight covenants require on-time COD, minimum pre-lease ratios, and healthy DSCR to protect lenders. Equity, core funding from controlling shareholders. DigitalBridge and Silver Lake acts as seed capital and credibility to attract senior lenders. Equity takes the highest risk, but captures the most upside once rental cash flow stabilizes. Green financing and securitization. As each building reaches stabilization, Vantage can issue ABS or secure green loans tied to LEED/ESG standards, refinancing at lower rates to reduce long-term capital costs. Objective: optimize WACC, keep leverage prudent for each phase, and retain flexibility to expand or restructure as GPU demand and lease signings surge. Estimated CapEx mix, power and grid interconnection: 20 to 25%, 345/138 kilovolt substations, transmission lines, overhead/underground cabling, protection relays. Costs hinge on interconnect capacity, HV equipment lead times, and interconnect approvals. Construction and MEP: 25 to 30%, structural shell, high-load floors, busways, UPS, PDU, auxiliary electrical, driven by rack density 100 to 250 kilowatts plus, and redundancy level N/N+1/2N. Liquid cooling 10 to 12%, CDUs, plate heat exchangers, chillers, primary/secondary piping, CRAH/CRAC, scales with next-gen GPUs. Network and fiber 3 to 5%, spine leaf fabric, cross connects backbone fiber to POPS. Land and site infrastructure 5 to 7%, land purchase/lease, grading, internal roads, drainage, permits, and environmental fees. BMS/DCIM and security 2 to 4%. Building management, DCIM, cameras/access control, fire suppression. Soft costs, contingency, and DC 15 to 20%. Design/engineering, project management, insurance, escalation reserve, interest during construction. Phase delivery. Phases 1 to 2, highest capital burn. HV substations, 345/138 kilovolts lines, relay protection, large approval risk, and long transformer/switchgear lead times. Construction loan drawdowns ramp here. Phase 3, structural shell and MEP, steady disbursement tied to rack density and redundancy standards. Phase 4, liquid cooling install, CDUs, chillers, piping, CRAH/crack, rises as high-density GPU clusters take shape. Phase 5, commissioning and tenant fit-out, testing, acceptance, handoff for tenant fit-out. Cash outflow shifts from heavy CAPEX to lighter interior spend. Revenue model hyperscale colocation with 10 to 15-year take-or-pay leases. Clients pay a fixed dollars per kilowatt hour per month, plus pass-through power and network/cross-connect fees. AI high-density commands a meaningful premium over traditional colocation due to 100 to 250 kilowatts per rack and sustained 24/7 utilization. Lease up strategy, pre-lease, a a portion of capacity to qualify for financing. Ramp occupancy by COD tranches, so rent cash flow aligns with capital drawdowns. Profit sensitivity, rental price dollars per kilowatt month, and lease-up speed matter as much as build cost. A swing of plus or minus $50 per kilowatt month or a cod slip of a few months can materially move IRR and payback. Illustrative math for a 1.4 gigawatt campus, 60% contracted by 2028, approximately 840 megawatts, approximately 840,000 kilowatts. At $400 per kilowatt month equals approximately $336 million per month, approximately $4 billion per year recurring revenue. OPEX, pass-through electricity, liquid cooling maintenance, staffing, land tax/lease, G&A, financing, debt service at prevailing market rates. Free cash flow equals revenue minus OPEX minus debt service, available for shareholders, reinvestment, or pay down. Key risks: ERCOT/interconnect, substation or 345 kilovolts line delays equals COD slips equals rent. Start lags, interest carry rises, large equipment scarcity, HV transformers, switchgear, backup generators, face global backlogs, equal CAPEX inflation, schedule drag, water and environment. Even with closed loop savings, full load WUE is unproven, equals potential permit tightening or ESG pressure. Rates and financing spreads. A multi-billion debt stack makes WACC highly rate sensitive, compressing IRR. GPU supply chain. Next gen GPU shortages equals tenants delay fit out/payments equals slower lease up and cash flow. Stakeholders and value share owner/GP standout IRR. If rents are strong, lease up is fast and COD hits on time. Risk of ballooning ID. C/interest if schedules slip. Banks and bondholders, interest and fees, price to construction/leasing risk with DSCR pre-lease and CAPEX covenants. DSCR pressure if COD slips. EPC/MEP, contractors, multi-year backlog and solid margins in HV. MEP, liquid cooling, exposed to lead time and material/labor inflation. Utilities, 24/7 baseload sales under long PPAS, risk of transmission congestion and major grid CAPEX. Local community, jobs and tax base growth. Con.